Hello, today we are providing a summary of the e516 course. Our cloud class will start with an introduction. As part of this, I would like to remind you about a previous presentation that I have given about my research interests. I would like to remind you that this class is not just about learning, but about you being able to actively participate in research opportunities. Topics of interest for research and other activities include cloud computing architectures, including NIST Big Data Reference Architecture, federated cloud computing, multi-cloud and hybrid cloud architectures, high-performance computing in the cloud and edge computing, which is exemplified on our autonomous robot board that you can actively participate in research at, big data applications, and here we have an example where we do scientific impact analysis, monitoring and visualizing clouds, cloud portals, and certainly other topics. You can, for the research, also contact me and we can discuss your interests. For the class, we are using very simple communication tools. Our main communication takes place through Piazza, which is a Indiana University approved tool for class communication. For code and documents, we are using GitHub. And I would like to remind you not to use my email addresses to contact me as part of the class. That's typically done for research that I do. Instead, I would like you to use Piazza. Absolutely no email needs to be sent to TAs. Only Piazza is supposed to be used. We will make sure that you are all enrolled in Piazza, and an assignment will be checked to make sure that you have posted to Piazza. To see more detail about what we are doing, you can see our class communication handbook, which is fairly elaborate and discusses these things such as how do you enroll in Piazza in much more detail than I can present here through this short presentation. Please use this handbook to understand how we are using Piazza and how you can enroll. As part of this class, we will define what cloud computing actually is. We will be revising and revisiting the NIST definition that is being given. We will look at the history of clouds and which technologies enabled clouds. In particular, we will be looking at the service model that promotes infrastructure as a service, platform as a service, and software as a service. Naturally, for the cloud, we need actual hardware. And as we are talking about big hardware and lots of hardware, they're typically moved into data centers to share the resources with other users. And we will be going into finding out how such data centers evolved, how a data center looks today, what's the difference between an academic research center, and where we find actually these resources all over the world offered by different vendors. Naturally, when we are trying to define multiple different applications, we want to share actually components with each other that are part of a unifying reference architecture. This is being achieved while we are looking at commonalities that are being identified by NIST so that we can define composable services. As such, we will be having a chapter about how we are using the NIST Big Data Reference Architecture, not only how we are using it, but how we extend it and define it. And you can become actually a co-author of that particular document if your contribution is being accepted. This is naturally a very unique opportunity, and not everybody has this opportunity, and I hope that you enjoy that we are making this available as part of the class. A significant portion of this class will deal with infrastructure as a service, and we will be providing you first with what the definition is, how we manage infrastructure, how do we use infrastructure, why we are using command lines, why we are using GUIs, why we are using programming, and contrast each other. We provide an overview of commercial and educational infrastructure as a services. In particular, we will be going into some architectural and vendor-specific provider offerings. This include OpenStack, Azure, Amazon Web Services, Google, and potentially Watson, but we may not have enough time. Possibly we don't even have enough time for Google. We will see how we proceed throughout the semester. A significant, important technology for cloud computing is virtualization. We will be introducing you to the different concepts of virtualization, which include machine virtualization and container virtualization. As part of the machine virtualization, we will be looking at QEMU, KVM, and virtual machines. Within virtual machines, we will be practically using VirtualBox. As part of containers, we will be looking at Docker, how we use Docker, how we define Docker files, how we use Docker Hub, and how we create our own Docker images. In addition, we will be looking into Kubernetes as well as Docker Swarm. Any class in cloud computing would not be complete if we were to be practically trying out cloud computing. In order to do this, we have to learn about how do we program it. And we have decided to not use Java, but we decided to use Python, as Python is playing a gigantic role nowadays in big data, as well as other programming activities related to cloud computing. For that reason, we will be giving you a short introduction to Python for cloud computing that includes the differences between Python 2 and Python 3, an introduction to Python as a language itself, how do we classes, and how do we use special packages that are extremely beneficial for our project within this class. This includes docopt, CMD, and CMD5, YAML, JSON. We will be going into how do you do module management to create your own modules. We will be teaching you about how to do a setup.py for your project, and how you host your code on GitHub and install the code from GitHub. As part of your project, the TAs are required to use your installation mechanisms from GitHub to run your code. To access the cloud, we will be using libcloud, which is a hybrid cloud library to access multiple clouds, and showcase you how you can manage your clouds through libcloud. We will be introducing you to REST services, and as part of this introduction, we will be showcasing you first how, for example, GitHub uses REST services, so that you can understand the mechanisms. Then we will be developing our own REST services with Eve, which is a simple way of defining REST services. And then we will be using a mechanism so that we can define REST services through an open API specification, so that you not only can develop and export them to Python, but any arbitrary programming language. One of the programming models used in cloud computing has been popularized early on in, for example, Google. And this concept is called MapReduce. We will be teaching you about what this concept is and how you can use this. And then we will be outlining differences between different systems, such as Hadoop and Spark, which are using MapReduce concepts. Another concept is that we need to be communicating with the cloud and the data services in the cloud. Therefore, we often use messaging. We will be introducing you to a state-of-the-art messaging framework called MQTT that can be used easily to forward messages between clients to cloud services, but also from the client to access information from the cloud services. Thus, we have a publish subscriber module that is supported by, for example, MQTT. In addition to REST services, most recently the term GraphQL has come up as one of the important technologies that we need to be researching. And this section introduces you to GraphQL, which is essentially a query language for graphs, and showcases you the advantages and disadvantages of GraphQL in contrast to other frameworks. One of the important activities at Google, for example, is to use Go for cloud computing. Go is a language that provides performance to you, and it's easily accessible to you. It allows you nicely to create REST services and interfaces with containers quite nicely. Go allows you to run your containers on Kubernetes easily, and we will be showcasing you how to do that and how to write simple programs in Go. This may be potentially useful for some of your projects because some of them you could be developing in Go if need be. Please consult with me if you should be choosing Go or Python. Typically, Python is easier to use. Unfortunately, we may not have time for going much into detail in Julia, which is a new computing language for distributed and cloud computing that can you use. And we will be maybe going into some details such as the language motivation. How do you do doc ops? How do you do distributed computing in Julia? How to do cloud computing in Julia? And as possible project, you can choose to re-implement Cloud Mesh with Julia. That includes accessing MongoDB, REST services with Julia, and containerization. Please remember that we may not have any lessons or lecture material on Julia. So if you choose this for your project, you would be best off choosing this also as your chapter and your tutorial project, and then combine your final project with it. Cloud computing deals with big data and big machines. So lots of computing power and lots of machines to execute them, and lots of data. In order to achieve lots of data, one other possibility could be achieving is that you, for example, look at all the cell phones that are out in this world, or all the sensors that are out in this world. And this is where edge computing and the cloud comes into place. How can we utilize these particular services and information pieces to use them in an analytic fashion within the cloud? So we will give you an introduction to how cloud computing and edge computing work together. We showcase this, for example, on a Raspberry Pi as an edge device. We are streaming data from the Pi, attach sensors, and you can participate in a project as part of the autonomous robot boat that we are creating. Naturally, we have many other topics as part of this class. One topic that may be actually really fun for you is to visit our Maker Lab. And this can be done with the residential students here at Indiana University. An example here is, for example, to create cases for the Raspberry Pi cluster that you will be developing, or laser cut pieces for our robot boat. We try to set up a 1 to 2 hour class with certification on Wednesday, either August 22nd or on Thursday, August 23rd. The certification means that you could be going to the Maker Lab yourself outside of the class and conduct your own activities there. As part of this class, you will be having to do some assignments. Some of these assignments, such as the notebook and the biography, are very, very simple. The notebook is just that you keep a notebook in Markdown format throughout the entire semester and write into this notebook what you have done in this class in which week. The biography is a formal bio similar to an IEEE format. Please look this up on the internet and write a formal bio and put an image, if you like to, into the formal bio and post it to Piazza. The more significant homework assignments is, for example, the contribution to a chapter. You have seen that we are using ebooks for distributing information to you. What we would like to see is that you pick a technology in the cloud environment or a topic that you further research and provide a significant chapter contribution to this handbook that we distribute to all of the other students. Examples could be, for example, the overview of all cloud services in Amazon Web Services. This is not just pasting and copying from the Amazon Web Services side, as this would be plagiarism, but this would be an analysis of the services that are there. Since these are many services, this could be broken up with many students in different portions. A chapter must be therefore a reasonable contribution that could be shared with others, but when you are doing a sharing, other people need to be contributing additional content to this chapter, or you need to be writing multiple chapters. As we are not only about theory but about practice, the tutorials assignment provides you the ability to test your skills on how to summarize a particular activity so that it can be recreated by others. Both chapter and tutorial are essential as a preparation to doing your project. You will learn in that skills that you will be reusing as part of your project. The project is your main deliverable for this class. Here you will have to develop a considerable project as part of your classwork. This project needs to be executable by the teaching assistants from source. So it is not sufficient to just wrap up your virtual machine or wrap up your containers and post these containers on archive storage systems so that they can be simply reinstantiated by the TA. No, the TA needs to be able to recreate the entire software platform that you have developed as part of your virtual machine or as part of your container. So for example, Docker files, make files, shell scripts, and so forth. The project could be in multiple different areas. So we have one area in which you could, for example, build a Raspberry Pi cluster. As part of this, you could be deploying, for example, Kubernetes. Another project could be deploying Hadoop, could be deploying Slurm, or any other service that are cloud related. Important is that you, as part of any project activity, you need to use at least one open API service to demonstrate that you have been able to master these activities. Project B could be that you build a significant open API REST service or services that support existing clouds. Such a thing could be, for example, accessing through Cloud Mesh via the REST services that you're developing, storage services from Box or Google or Azure or Amazon. Or you could be creating a Cloud Mesh enhancement to execute code on Watson. Project C would be that you build your own edge service that interfaces with the cloud through an open API REST service. This includes maybe our robot boat, or you have other ideas about edge services that you are interested in, and you could be focusing on this kind of a project. The last type of project is that you define your own project. Please come and get in contact with me so that we can discuss what you would like to do. We will be having a project discussion session explicitly at the end of the first month of the class. It's a strict warning that tutorials, chapters, and especially projects are multi-week projects. So do not be tempted to execute them a week before. You will significantly fail. We anticipate that you need to be working on, for example, a tutorial for 1 to 2 weeks, on chapters for between 1 to 3 weeks, dependent on the background that you may have. And the rest of the time you actually work on your project. Notebook, if you spend more than 10 minutes on your notebook per week, you're doing certainly something wrong and you should contact me. To make scientific writing as part of the projects and chapters easy for you, we have provided you with significant information about how to easily do this. You don't necessarily have to read everything that we are writing there, but it is significantly documented. So there is, if you ever want to look up some stuff, you can use our Scientific Writing 1 and Scientific Writing 2 handbooks. In that, we will be explaining to you, for example, how do you avoid plagiarism and cheating and use Markdown. We will also introduce you how to write a high-quality project report following our template. We would like to point out that the template is very simple You may be initially thinking this is just complicated, but in fact it is simple if you just follow our directions. Don't do anything special, just follow our directions. It will work for you. These skills will be extremely useful for many other classes that you take at IU or any other university. So I would recommend that you early on explore this and figure out how do you utilize them fully. With this, I would like to conclude this discussion. And if you have any questions, please use Piazza and issue your question on Piazza. If you can't enroll into Piazza, please contact one of our TAs. This is the only time we allow communication with them in other forms. Typically, what you need to just do is follow our instructions. We had hundreds of students having no issue with enrolling into our Piazza. Please follow them carefully. Don't just pass and copy our information. This can lead to problems. Read the information first before you do some stuff. This is also applying to any other tutorial or any other material that we are providing. It is important that you read that material first before you do it.